From Bloomberg News and iHeartRadio, it's The Big Take. I'm Wes Kosova. Today, tech startups are working on ways to get inside your brain. Devices that can interpret signals in the brain and allow a person to move a mechanical hand or a mouse cursor on a screen have been around for a while. But recently, brain-computer interfaces, or BCIs as they're called, have taken a leap. Rapid advances in both medical technology and just plain tech have opened up new possibilities for using small implanted devices to improve the lives of people with any number of limitations.
They plan to look at epilepsy, stroke, dementia, traumatic brain injuries. They want to put chips in or near your brain to treat depression. So there are lots of doctors and scientists thinking very creatively about how to use all of these.
That's Bloomberg reporter Sarah McBride. She covers this corner of the tech world, and a little later in the show, I'll talk to her about the growing number of startups looking to bring these devices to market. First, though, let's get a look at one of them ourselves. Dr. Tom Oxley is a neurointerventionist and CEO of Synchron. That's a startup that's working on a device to allow paralyzed people to control their iPhones or search the web or just call up a movie on Netflix with their thoughts. He agreed to give us a tour of his lab in Brooklyn, New York. Synchron's office is typical tech startup. Big open room, desks and computers, couches in the corner for collaboration, and free snacks in the kitchen. Across the hall is the lab. It's a large, raw warehouse space that's divided in two. On one side, in true startup fashion,
we have a pickleball court, which is very popular.
The other side is filled with workbenches that are strewn with electronic equipment, and on one of them is the device we're here to see. Are we able to see one of the devices?
Yeah. Take you back over. Right. So this is the device. I'm from a colonial state of Britain, so I use the metric system. So I'm holding about a 50 centimeter lead. The lead on one end has a self-expanding stent, which is similar in look to the type of stent that you might have if you have a heart attack.
I'm going to try to describe this thing. The stent is an open weave of this whisper-thin silver wire about the length of a medium paperclip. There's an array of tiny dots. They're sensors. Oxley likens them to microphones, and they sit where the wires cross over each other. The device collapses down small enough that it can be inserted through a vein in the neck, and then it expands once it's in place. And the stent is attached to a long coated cable of bundled wire about as big around as a piece of angel hair pasta. There's one wire for each dot. And as I understand it, over time, it embeds itself within the vessel, which makes the signal stronger.
Exactly. So think of that like a tattoo. The cells grow over the system, the ability to record local brain activity is better once it's encapsulated in tissue, and it stays there, and it generates no ongoing, we're going to prove that it generates no ongoing inflammation. But we feel good about that because there's a long history of decades of the use of stents in the heart and brain, and we're using the exact same materials that have always been used for these systems, so they can live in there like a tattoo for a lifetime safely. And then on the other end, you'll see a plug, and the plug goes into it's kind of like a AirPod container for the Apple AirPods, but it's thinner than that.
Yeah.
It's a little bit elongated, and it sits under the skin, so you could feel a little bump in the chest if you had one in your chest.
And then the wire runs beneath the skin.
Yeah, this is all implanted in the body, and then there is a Bluetooth protocol that sends the information out of the body. So then we get to the external components, and if you imagine there's an external component about the size of an iPhone, I would think of this like a Bluetooth mouse. that is able to connect to any device and give control over a system.
Does the battery run for years similar to a pacemaker, or does it require charging?
It runs for years.
Once the stent is implanted and hooked up, those tiny sensor dots attached to those wires can start listening to the brain's signals.
So the brain has about 80 billion neurons, and each of those neurons has electrons running down a bit of cell tissue, which is called an action potential. And the action potential generates a firing of the neuron. If you were to listen to them, it would, sound like a whole bunch of fireworks across the whole domain of the brain. And depending on how close you are to each individual neuron, you can hear activity that relates to certain functions. So the brain is broken into functions. And if you're in any of those domains and you see the brain firing, you can presume that there's some processing of information as it relates to that domain. For us, we can't get down to the individual neurons, but we can hear the firing of populations of neurons, and that looks like changes in voltage. So we literally are recording changes in electron flow that represent activation of brain tissue in real time that's nearby the sensors.
To record those changes in the flow of electrons, the device needs to be as close to the brain as possible. Synchron does that by going in through the jugular vein in the neck.
Yeah, so one thing that might be worth pointing out is that we are building technology that goes into the veins, not the arteries. So the arteries carry blood into the brain, and if they get blocked, then you're stopping oxygen getting to the brain. The veins are the drain pipes of the blood out of the brain, and we're coming up the backside, up the drain pipes. So the jugular vein is in the neck, and we move backward to the flow of blood up the jugular vein. We take a turn into what's called the transverse sinus. We take another turn into the superior sagittal sinus, and that is a big pipe that carries up over to the top vertex of the brain, and that is where the motor cortex exists. So we actually stop there, and the reason we've done that is because it's a safe domain to be in. It's a large blood vessel. It's got access to the motor cortex. It's quite robust. There are other blood vessels that we're starting to work towards that are going to give increasing access to more motor cortex, but we're staying within that domain. To get into the jugular vein, if you just touch your collarbone into your neck, just above the collarbone, you're probably touching your jugular vein. So we'd put a little needle in there and then put a wire and then a catheter, and then push that up, heading upwards. And the catheter goes up through the base of the skull into the brain.
Oxley says it actually isn't that big a deal to get the device in place.
The procedure is not performed in the operating room. It's performed in a cath lab. The patients lie down on a table. We don't cut open the skull. You use a catheter to slip your way up blood vessels into the brain, and we can deliver all sorts of things. And what we have figured out is how to deliver electronics into the brain.
So what does that look like in real life? A patient has the device implanted, and then what are they able to do? What would be an example of something that a person could do with that ability to metaphorically click the mouse?
So on the Apple iPhone, there is a way in which you can start to control the iPhone without having to touch the screen if you have an ability to send command clicks into the iPhone. So we have our patients sending their command functions, and we've integrated into the iPhone where they're able to navigate their way and use the iPhone. It's not as fast as what you and I can do with our fingers, but Apple have created mechanisms of accessibility control that allow these types of inputs to work. So that's a really big deal. We're giving our patients back control over the iPhone. We're also working on a Windows platform with a different approach. But the thing that we're realizing is for people who are severely paralyzed, what they primarily want is a stable, robust, easy to use, rapidly responsive system that doesn't fail. And so we have to be careful if we go for too complicated training programs or calibrations, or it very quickly becomes frustrating to use. So we've really got to approach around simplicity and robustness from what we're hearing our patients want.
So this enables people to, say, send a text message or to search the web?
Well, I mean, once you've got control of your iPhone, you can do whatever your iPhone can do. But the things that are relevant, we think, from a patient perspective, are basic elements of, what you might call digital activities of daily living. Sending text messages, checking your email, responding to an email, checking your bank account and making a payment, doing some shopping, arranging your medication, joining a call with your physician. All those things can mean that you don't need someone else around you all the time helping you with these things. That's the goal, is improving independence.
How close is Tom Oxley to reaching that goal? We'll talk about that after the break. Now that we have a good idea of how Synchron's device works, I asked Tom Oxley how close he is to bringing it to market.
We have an early version that's in trial with a low number of human subjects. The FDA has approved 6 subjects in the US. We've done 4 in Australia.
And those are subjects that have been approved to receive the device.
Yeah, these are people who have severe paralysis, who can't use their hands to control digital devices that you and I have become probably addicted to. So replacing lost hand function due to diseases such as spinal cord injury, stroke, ALS, multiple sclerosis.
And how long will the trial last?
The formal assessments of safety and efficacy, which is how well the device works, will be assessed over a 12-month period, but the patients keep using the device after that point. And we're learning from the people who are going through lives with paralysis. We're still learning what the needs are. We're in a position now where we are looking to be the first company that's going to go through this process in the discussion with the FDA. And it's going to set the scene for the industry.
And when does it begin?
Well, we are hoping to launch our pivotal study within 2 years. A pivotal is a phase 3 study, which generally means that you have to set a outcome which you agree upon is clinically meaningful, is like it means something that is useful for the patient and is going to improve their lives. And you achieve that in the study in a pre-specified, controlled manner. The feasibility stage, which is what we're in now, is more about preparing to, test certain methods of assessment to know that you're on the right track to demonstrating, a very clear-cut level of impact for the patient.
I asked Oxley where his company fits into this growing universe of tech startups that are all exploring ways to use brain-computer interfaces.
So firstly, we are within the implantable brain-computer interface domain. Within the implantable brain-computer interface domain, we are the company that are confined to the blood vessels. So the word intervention is, interventional neuroradiology is the method with which our technology is implanted into the brain. The other companies in the implantable space are removing at least some amount of skull to deliver hardware into the brain. There are pros and cons with being in the blood vessel. The procedure is less invasive in that there's no disruption to the skull. However, we can't get as close to individual neurons in the brain because we stay within the blood vessel. That's bad because we don't get as much information, but it's good because there's decades of evidence to show that existing in the blood vessels over lifetime can be safe and stable. The challenge for us is with lower data rates coming out of the brain, but with a system that we anticipate to be stable, what does that mean in terms of what the patients are able to perform? If I was to look forward, with more and more access to more regions of brain, more information flow can happen, and the more information flow can happen, the more the user is able to engage with systems. Our brain's computing powers goes far beyond that of our ability to communicate our current state of our brain. And this technology will use that as a mechanism of overcoming problems that we otherwise can't solve because of the limitations of the human body.
Let me ask you some of the dystopic questions that I'm guessing some of our listeners might be wondering. I know I am. Can this thing be hacked? It uses Bluetooth, which is not always the most secure thing.
So privacy and security are a big focus for the FDA and have been a discussion point between us and the FDA. And I mean, hacking, I don't quite know what that would look like. I guess kind of in the same, it would be like saying, can a Bluetooth mouse get hacked that's controlling my computer? So if the computer gets hacked, things can be done, but it's not like your brain can get hacked because it's really like you're controlling a joystick. The US government's been investing in this space for decades, and it's now starting to mature into an industry, and we're seeing commercial offerings on the horizon. It's very exciting, and I think for patients that, just to give you an example of what patients need this technology, the patients that we're dealing with right now, they go to bed, and a family member told me a couple of weeks ago that they can't fall asleep themselves because they don't know that their father, their brother, whoever it is that's in the other room, has a way to call out if there's a problem. So if you are not able to move the muscles in your body or talk properly or use a device, how do you call for help? How do you reach out? And there are some systems out there, but I think what BCI has the potential to solve that issue of always being connected when you want to be connected and reaching out and using digital systems to engage in your world. And you and I take that for granted. We all sleep with the phone within arm's length away from us, and we wake up in the morning and we grab it straight away. This technology enables people who don't have that use of their hands to engage in a way that you and I take for granted, and that's what this is about.
Tom Oxley, thanks so much for speaking with me today.
Thank you very much.
When we come back, we'll hear about other companies that are also working on these brain-computer interfaces. As we've heard, Synchron is just one of several tech companies working on these brain-computer interfaces. Sarah McBride covers venture capital and startups for Bloomberg, and she's here to tell us what others are working on. Can you tell us a bit about why brain science has taken off so quickly?
Well, I think there's something about it that just captures the imagination. It just sounds so futuristic and crazy, but then I think people can imagine the possibilities. Then I think people see that some of this is real. They read about trials. For example, at Synchron, people have Synchron devices in their brains. So it seems to be actually happening. And you can imagine a time in the future when there'll be a few thousand people walking around with these things in their heads.
How long has this technology been around?
The truth is, it's been around for years, 20, 30 years, depending on what event you choose to date it back to. There's a company called BlackRock Neurotech that's been doing this for decades, but nobody really paid attention to it until Elon Musk came around. And when Elon Musk, who has a track record of getting things done, said that he was going to work on this, everybody started paying attention. But there have been some versions of this used for a long time. When I first heard about it, I thought there's no way anyone would get chips of any sort put in their brain. And then I learned that there are a lot of people who have epileptic seizures who have chips in their brains that try to stop epileptic seizures. There are people with Parkinson's, same thing. So I realized, yes, there are certain people who would definitely do this.
A lot of the different startups that are working in this area seem to be trying to address medical conditions like Alzheimer's or other diseases, or physical limitations that allow limbs to operate or other things like that. But are there other people working on things that don't have to do with trying to fix something, but just trying to extend our capabilities as humans?
You know, Wes, I think there probably are people working on that type of thing, but they're keeping very quiet about it because it just sounds so freaky. So I've heard people say before, why don't we just download languages into our brains? I've actually talked with somebody about, is that possible? And it sounds like we can't do it now, but theoretically it would be possible. However, your brain is a little bit like a hard drive. If you downloaded an entire language like Japanese, then there might be limits as to what else you could put in there. Every time Elon Musk talks about this, he mentions crazy things that I think, oh, that's surely not possible. He has said, oh, I'd like to download music directly into my brain, listen to music play directly into my brain, or I'd like to cure addiction with Neuralink. And every time I heard something like that, I thought, oh, he must be really stretching it now. That can't be true. And then I would go find some very smart people who tell me, well, that's not possible now, but that's not actually impossible. Theoretically, we could do that with a device like this. So every time I thought something sounded outlandish, when I looked into it, there were actually smart people who told me it wasn't as outlandish as it sounded.
Can you tell us some of the companies that are doing this and what they're coming up with?
Sure. So there are a handful of players that are pretty advanced. And by advanced, I mean they are either close to getting approval for clinical trials or they have clinical trials in process. One of the companies that already has an early trial in place is Synchron, which you just visited. BrainGate and BlackRock, and this isn't BlackRock, the investment bank, it's BlackRock, the company that makes BrainGate. They published the first results of their device in humans in 2006. So that was somebody who could control a click on a computer screen. Very simple robotic devices. And then they went on to do robotic arms after that. But that was chips in brains. When Elon Musk started talking about Neuralink, he said he wanted to help people with severe brain injuries. And he specifically mentioned stroke and cancer lesions and other types of challenges that patients have. And they seem to have kind of homed in on paralysis, and they've also talked about blindness.
And have they had success in helping alleviate these problems?
Not in people. They're trying to sign up patients right now. They've tweeted about, if you ever have any interest in being in a Neuralink trial, please register here. That doesn't mean that they're in humans yet. Like, that's just kind of building up a database so that once the FDA gives them permission, they could start implanting their devices in paralyzed people or whoever it is.
What's another company that you've looked into?
The former president of Neuralink, Max Hodak, started a company called Science, and he has a few ex-Neuralink people working there. One of the problems they're working on is blindness. And just as Synchron wants to use blood vessels as a backdoor into the brain, Max Hodak at Science wants to use the optical nerve as a backdoor into the brain. Precision Neuroscience, founded by another co-founder of Neuralink, Ben Rappaport, has said that they plan to look at epilepsy, stroke, dementia, traumatic brain injuries. There's another category of company that might not be considered brain-computer interfaces, but they want to put chips in or near your brain to treat depression. There are companies that are already using chips to treat things like epilepsy. So there are lots of doctors and scientists thinking very creatively about how to use all of these.
So who's funding these companies? Where does the money come from?
I've had a number of founders tell me that there's no way traditional venture capitalists would normally fund this type of company and probably wouldn't have backed any of them except once Elon Musk got involved. And now some pretty mainstream venture capitalists are getting involved and funding some of these companies. Also, neuroscientists and doctors who might have gone into some other type of medicine are now considering working in the field. There are a lot of bright people attracted to it now because of the Elon Musk halo, but also mainstream health venture capitalists like Arch, for example, is one that's backed a couple of these companies. And it's something where you can also get government grants. And there are a lot of research universities where people are doing a lot of the preliminary work and then starting companies based on what came out of their university lab.
When you look down the road, given how fast this technology is changing, what do you see 5 years from now? What are some of the things that you think will actually be in use by then?
Honestly, 5 years from now, I think there'll be a lot more trials. I think there'll be bigger trials, the type known as pivotal trials. I don't think you'll be able to go to your doctor and get a prescription for this the way you could for LASIK now. I think maybe in 10 years, but 5 years is, I think, still too tight a timetable. But in 10 years, I think it'll be more like the early days of LASIK. And then in 20 years, I think it won't seem that out of the ordinary for people to have some kind of brain implant. Right now, I've talked to patients who are in some of these trials. I had one young woman who is trialing chips for her epilepsy who told me, I'm the bionic woman now, because she had chips in her brain and she felt very kind of special and unusual. I'm not sure that it'll still seem special in 20 years, but 5 years, yes, it's still going to be pretty unusual.
Sarah McBride, thanks so much for being here.
Thank you so much, Wes.
Thanks for listening to us here at The Big Take. It's a daily podcast from Bloomberg and iHeartRadio. For more shows from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen. And we'd love to hear from you. Email us questions or comments to bigtake@bloomberg.net. The supervising producer of The Big Take is Vicki Vergolina. Our senior producer is Kathryn Fink. Rebecca Chaisson is our producer. Our associate producer is Sam Gebauer. Gilda Garcia is our engineer. Our original music was composed by Leo Sidran. I'm Wes Kosova. We'll be back tomorrow with another Big Take.